Traditional video incident detection systems that have been used for the last 20 years have proven not to be sufficiently precise. They have proven to have low detection rate and high false alarm rate. In some weather and traffic conditions, traditional systems fail to detect up to 60% of real incidents. Moreover, they have many false alarms, usually 2 to 3 false alarms per camera per day. These statistics are not acceptable for securing traffic safety. That is why video incident detection systems are not a mandatory part of traffic management centers anymore. This is unfortunate, as video is an integral part of every traffic management system and should be relied upon to detect disturbances and accidents. The main reason for low performance and bad statistics is that the cameras are capturing videos in real traffic and weather conditions. The real conditions have sometimes proven to be unsurmountable for traditional video systems. Traditional video systems recognize the objects of interest by focusing on the difference in pixels between consecutive frames. Objects of interest are vehicles, pedestrians, or debris. By detecting different types of changes in pixels between frames, traditional systems try to detect irregularities in the movement of vehicles and other objects to detect the underlying alarm situation. This approach is not optimal, and here is why. When a camera is shaking due to wind or vibrations, there is a constant change in pixels of consecutive frames. During heavy snowfall, the visibility is low and the video feed is not that clear. Rainfall and raindrops on the camera blur and obstruct the camera view. A big difference in lighting on the road between daytime and nighttime might cause huge differences in pixels and in the entire scene within the frame. Dirt or snow accumulation on the lens might cause false debris alarm. Often vehicle headlights blind the camera. If pan-tilt-zoom cameras are used, traditional video incident detection systems won't be useful because the frames are changing with every camera move. Light reflection off a wet surface very often causes false alarms. Contrasting moving shadows within detection zones might activate a false wrong-way driving alarm. If the cameras aren't placed perfectly above the road, this might cause problems with detection. Nighttime conditions and low video quality are often a big problem for detection accuracy. All these challenges, although not a result of object movement, nor an incident or alarm situation, do result in changes in pixels and consecutive frames that could cause false alarms in a traditional video incident detection system. To compensate for false alarms, the traditional systems are often calibrated to be less sensitive, which results in low detection rate. Unlike traditional systems, XAID uses machine learning and artificial intelligence to precisely learn how to detect objects of interest within a frame. XAID is capable of learning what objects of interest, vehicles and pedestrians, look like in real traffic conditions. Simplified, this means that XAID system looks at the attributes of the object of interest, like a number of wheels, height, color, etc., and creates a 3D mental image of the 2D object of interest in the frame. Once it recognizes the object, it knows that the object can only move in a certain way on the stretch of road in the frame. Besides recognizing the object, there are many other algorithms working simultaneously, like background subtraction, edge recognition, etc., that make XAID a powerful tool. Once the system learns to recognize the objects of interest, it is capable of tracking the object of interest within the frame and deduct it if there is a problem. XAID associates object movement with its physical attributes, ignoring the possible deviations that are caused by real traffic or weather conditions. That's what makes the XAID detection very reliable. Shaky cameras will not pose any problems, as the system will know that a vehicle can't jump around in a frame. Low light or wet surface reflection won't cause problems because the system will know it's just a background. Sun reflection doesn't present any problems for XAID system. Vehicle headlights will not affect the efficiency and reliability of the system. XAID will recognize a vehicle as soon as its contours are visible. Light reflection doesn't influence the vehicle detection, as it is not recognized as a part of the vehicle, thus doesn't cause false alarms. Differentiating shadows from objects of interest is what gives XAID the upper hand in completely eliminating false alarms. Whether it's static shadows that suddenly appear and disappear, which causes traditional systems to falsely report debris, or moving shadows within detection zone that often cause wrong-way driving false alarms. Why? Because a shadow doesn't have the attributes of the object of interest. Advanced object of interest extrapolation and filtration methods allow XAID system to reliably detect vehicles, even in extremely low visibility, whether it's raindrops on cameras that blur the image or extreme snow conditions. XAID's unique ability to track the object, consider its physical properties and expected trajectory, allow the system to continuously track vehicles, even in case of a short-term loss of the vehicle within the frame. Poor camera position in reference to the horizon in traditional systems introduces unreliability and very frequent false alarms in times of changing weather conditions. The XAID system can fully compensate for changes in the image created by different lighting and weather conditions, which makes it one of the most reliable incident detection systems in the industry today.